In this lecture, discuss about the digital circuit using diode transistor logic. So first of all, we discuss about OR gate. So what is the output equation of OR gate? Y equals to A or B. So using diode, this is a two diode, which is also known as PN junction diode, are connected in parallel, and one resistance are connected from here, and here two input are AB, and here one resistance R, and this is output. So now according to the truth table, when both input equal to 0, then the diode is off and the output equal to 0. When any input equal to 1 or both input equal to 1, the diode start conducting current, and here the voltage equals to I into R, that means V0 equals to is I into R, and you're getting the voltage drop. So this is then the OR gate circuit using simple diode arrangement. But here one problem arises. What is the problem? Because the cut-in voltage of the diode is 0.7 for silicon and for 0.3 for germanium. So this here, if we apply here logic 1, then this logic 1 means the 5 volt. So 5 minus 0.7, 4.3 voltage, 4.3 volt we getting from here, not 5 volt. Okay. So this is the disadvantages of DTL circuit. In the next part, in the next video we all discuss about the DTL circuitry. But in a complementary MOSFET or MOSFET technology, this degradation of voltage is overcoming, and so this is the basic primary advantage and disadvantages between primary advantages of CMOS over the DTL and TTL technologies. Okay, so if we in the next we discuss about basic AND gate circuit. So this is the connection of these two diode, and here we connected plus VEC, that means 5 volt, and from here we connected 1 voltmeter, and here we connected 2 input. So now if both input equal to 0, then the diode start conducting, and the potential drop here 0.7. This is a low voltage. So when 0 and 0 apply, then output equal to 0. When 0 1, then one diode is conducting, so this is also equal to 0. When 1 0, then also one diode conducting, that means 0. When we apply 1 1, then no diode is conducting. Okay, so the high voltage is just appearance here. So this is logic 1. So this is the output equation of AND gate. Okay. Now in the next we discuss about the NOT gate circuit. So for NOT gate using transistor, and here we apply the mechanism of transistor as a switch concept. So when V input equal to 1, this is a truth table. When V input equal to logic 1, that means 5 volt, their current is conducting, and 0.7 is the breakdown potential, and if base current is flow, then collector current is flowing, and here the voltage drop is arises, which is IC into RC, and this VCC minus IC into RC, we get the low voltage across here, that means V0 equal to 0 voltage. But when V input equal to 0, no base current is flowing here, because 0.7 is breakdown potential. Here collector current equal to 0, and voltage drop across the resistance RC equal to 0. So what is output? Output equals just equal to the VC. So this is the concept of NOT gate. So here you see that if we apply 1, then output 0, and if we apply 0, then output equal to 1. So this is a basic inverter circuit or NOT gate circuit using transistor, and here transistor operates in a two region. One is cutoff region and another is saturation region. Okay, so these are the two concepts, and in the previous slide we discussed about OR gate, AND gate, and this is the application of NOT gate. Okay, so now this is known as the DTL technology, diode transistor technology. Okay, so next we discuss about the AND gate circuit, Y equals to A dot B whole bar. So what is the circuit arrangement? The circuit arrangement is look like that. Here we connect one resistance, here we connect two diode to avoid the noise voltage effect. For turn on and turn off the base emitter, these are two resistance, This is RC resistance, this is plus VC supply here, and this is R1 resistance. Here we apply two input voltage A and B. Suppose these two input voltage equal to 0, 0. So diode is start conducting current here. Okay. So what is the voltage drop here? So the voltage drop here equal to 0.7 volt. So 0.7. So the cut-in voltage of diode is 0.7 and 0.7, that is 1.4 here. So practically there is no base current is flowing, because here also 0.7 voltage are the breakdown voltage. So here base current equal to 0, that means collector current equal to 0. So what is output? Their collector current equal to 0. So output equation is, we know that VC minus IC into RC. So collector current 0 means the output equal to 1. So when AB equal to 0, 0, when AB equal to 0, 0, the output is getting equal to 1. When 0, 1, then also 1, because one diode is conducting. When 1, 0, then also take same action. When we apply 1, 1, then no diode start conducting. Then there is no diode from which the current is conducting. So here potential equal to plus VC 5 volt. So these 5 minus these voltages are make to flow the current in the base region, and here also flowing the current IC, and we will get a drop IC into RC. So this minus this equal to the 0, logic 0 we apply here. So this is the basic truth table of the two input NAND gate. The question arises, why you use these two diodes? These two diodes are used for to avoid the noise voltage across the base of the transistor Q1, because if any certain noise voltage are captured in the base region, then base is turn on or turn off, and this is not a predictable, this is not determine the predictable voltage across the input to get the proper output. So that's why here we use two diode. Okay, so this is the basic circuit of diode transistor logic to make the NAND gate circuit. So now in the using only the transistor, we also make different circuit. This is one transistor, this is another transistor, and here one connect emitter resistance. So now in this circuit, this is RC, this is also RC, this is RB, this is RB, and if here we apply AB input, and from here we get output, this is RE. So we plot the truth table and output B0. When both input equal to 0, 0, no transistor are conducting current, then 0. When 0, 1, one transistor is conducting the current, that means the current is flows from here, and output voltage equal to logic 1. This is same for this, and when both transistors equal to 1, then also output equal to 1. So this is the circuit of OR gate. When two transistors are connected in a parallel combination, so this is also known as a OR combination. And when the two transistors are connected in a series combination, this is known as AND combination. How we study it? This is plus VC, one base resistance connected here RB2, and here RB1. Here two input are applied, A and B, and from here we get the output. So now again we discuss about the truth table concept. When both 0, no transistor is turned on, that means here current equal to 0, so voltage equal to 0. When 0, 1 means the upper transistor is in cutoff mode, so no current is flowing, so output equal to 0. When 1, 0, lower transistor is cutoff mode, that means output also equal to 0. When both equal to 1, then this base emitter also on, this base emitter region also on, then two current are flowing in this transistor. So from here, from the supply, collector current is flowing in the emitter, and this emitter current also the collector current and also the emitter current, and here voltage drop equal to 1. So this is the concept of basic AND gate circuit. So using this transistor and diode technology, we will design different types of logic gates. Okay. So now one example for TTL series. In the TTL there are so many concepts. One is totem pole. In the next video we discuss about elaborately totem pole concept. One is open collector type one is open collector type, another is emitter coupled logic, which is also known as ECL technology, emitter coupled logic. Okay, but today we only discuss about basic diode transistor and transistor logic. Okay, this totem pole, open collector are and emitter coupled are the depend on the variation of the output to getting the different types of output signals from the transistor technology. Okay, so if we discuss one more circuit, that means in this digital circuit, this is first one AND gate, and from this AND gate one NAND gate also connected, which is input equal to C. So this is a digital circuit. So what is a analog circuitry? Equivalent analog circuit of this circuit using transistors, okay, or using diode transistor, anyone. So first of all, this is AND gate. So this AND gate is like this diode, this and diode. Here we connected one resistance, and this is plus VC. Here we apply two input A and B, okay, and here also one AND gate is connected. So AND gate means one diode is connected in a backward direction, because in the previous lecture we show that this is an AND gate connection. This is an AND gate, okay. So that means two diode. This is one diode for this input, and another diode. This is the external input C, okay. These two diode and one resistance is connected here, known as R1. These internal two diode are connected for avoid the noisy voltage of this is an output. This is R2, this is RC, this is short circuited and also known as VCC, this is ground, and this is output. So this is the diode transistor technology. So first of all, this just showing in the different color. Just a minute. Okay, now first of all, this is an equivalent circuit of this AND gate. So this block is equivalent to this, and this block is equivalent to this. Okay, but in a practical there are so many problems, like a fan in, fan out, or impedance matching. There are so many problems. We just talk about the basic circuit application, basic circuit, analog circuit, which is internally connected in this digital circuit. So this AND gate symbol is just for the given by the IEEE, these IEEE standardization gates. Okay, so because in a practical scenario, in the all time we cannot draw this circuit because this is a very complex circuit. So we just denoted by this symbol. Okay, so this AND means this like this symbol is like look like this. But the basic operation of AND gate is make addition with diode or transistor logic. Okay, because in the digital there is also present the analog. So using analog we make the digital. Okay, because in an analog circuit there are two important points are coming. One is cutoff and another is saturation. So depending on these two values, the digital circuit is designed. So without analog, the digital circuit is not possible. Okay, it is impossible to design the digital circuit without analog circuit. So analog is everywhere. That's why analog circuit is very important.